Good afternoon, everyone. Welcome to the Neo4j Twitch channel. My name is Adam, and today we'll be continuing a series on building web applications with Neo4j and TypeScript. So to recap where we are so far in the project, we're working for a fictional client called Neo4j. So Neo4j are a video streaming service that allow users to buy monthly subscriptions to film and TV shows. Maybe familiar to some software as a service site that you use at the moment. In week one, we installed the Nest.js command line tools and then basically dived into the fundamentals. So we ended up the session with a Neo4j module. And so this Neo4j module basically takes the configuration object, so in this case from the configuration service and from a .env file, and then loads that into a config object, and then uses that information to build an instance of the Neo4j driver. And then that driver is then created as a injectable item that can be injected into any service. So then created a Neo4j service, which took the driver and the configuration and just gives you a way to interact with Neo4j, so either read from Neo4j and write to Neo4j in an easy and convenient way. And so I got this tweet a little bit earlier in the week from Fabish. Please can you add authorization, so user registration and login to the series on applications. And so this will be the focus of today's session. But today my aim is to build a user module which will allow us to interact with Neo4j and perform actions around a user. So for example, creating a user or logging a user in. An authentication module which will take care of the sign up and the authentication. We'll look at using pipes and guards to validate HTTP requests in Nest. And then we'll look at also testing as well. So we'll look at implementing the end-to-end test to allow us to verify that things work. Cool. So if we jump into the code. So really, the authentication is a really important part of any subscription site. Ideally, what we want to do is for every request, we want to be able to verify who the user is and also check whether they've got the correct subscription and to check they have the correct permissions to do what they're trying to do. So in today's session, we'll look at verifying who the user is. And then in a subsequent session, we will look at authorization, so deciding whether they can do what they're trying to do or not. So there's a great piece of documentation on the Nest.js site, so docs.nest.js.com. So if you go to authentication, there's a great write-up on the techniques and how you should implement authentication. So we're going to take it a step further. This is a generic approach, but what we're going to do is we're going to make it Neo4j specific. But we're going to be using some of the same things that this guide is talking us through. So for example, we'll be using Passport. So Passport is a middleware for Express, but the whole purpose of Passport is just to authenticate requests. So the first thing that we should be doing is creating a new service for our authentication. So as we did in the previous sessions, we'll use the Nest command line for this. So I can call Nest and then G, which is a shortcut for generate, and I want to generate a module, and we'll call that the auth module. Then we have this new auth folder here, and we have this module. So a lot of our work will work around this today. We also want to generate an auth service, which will allow us to use that functionality across the application. So you can say Nest G and then S for service, and we'll call that the auth service. And then this generates the file for us. It also generates a test, and also updates the auth service to say that this is a provider, or anything inside the auth module will be able to access that auth service through the dependency injection. Next thing we want to do as well is to create a controller, so nestgco auth. And this will hold our HTTP routes for logging, sign up, and for registration. Cool. And then the next thing to do is to create a module and a service for the user, so then we can follow the same conventions and the same patterns. So if I say Nest G and then mo user, it'll create the user module and then register that in the app module. And then I want to create the service as well. So Nest.js user. And the requirements for the user module is that we want to log the users in using username and password. So instead of having a specific username, what we'll do is we use the email address as well. So one of the things that we want to do in the Neo4j database is we want to create constraint on the user against the email address. So ensure that the email address itself is unique. So the way we do this is inside Neo4j browser or inside Cypher Shell, whichever you prefer. We can run a create constraint command. So we want to create constraint on which is a user, and then we want to assert that u.email is unique. So I've already done this, so if I run this again, then I'll get an error saying that the constraint already exists. But I can see here that the user email is unique. So now if I try and create two users with the same email address, then I'll get an exception thrown back. Cool. So if we jump back into the code, so basically what we want to do here is to essentially follow the instructions that we have here. So that the first thing that we want to do is we want to create an endpoint, like HTTP endpoint, so we can authorize the user. So inside the Auth Controller, what I can do is I can create a new route, and this will be, for example, a post route with an endpoint of register, and then we want a function inside there, so it would be post register. Cool. And what we want to do is we want to bring in the post body, so we can use the body decorator. And then this will be, for example, user. So Nest will map the body of the request to the user. So the way that it works inside Nest is that we would create a DTO or a data transfer object. So a DTO looks a little bit like this here. So you have, in this example, the create cat DTO. So what you do basically is you create a class which then maps all of the values from the payload into an object. So first is we'll create a directory, so the source user and then DTO. So once we've created that folder, we can then touch the file just to create it, DTO, and then create user DTO. So essentially what we do is the same as this DTO here. All we do is we create a new class. So we will export out a class. We'll call it the create user DTO. And then we define what we want from the user. So when the user is created, we want some information about them. So some required information, and then there'll be some information that we don't necessarily need. So for example, we want the email, which is a string. I want the password, which will also be a string. And then we want the date of birth. So the date of birth will be important in this project. So for two reasons. So firstly, we want to make sure that the users that sign up are more than 13 years old to comply with UK law. But also what we want to do is we want to make sure that user is able to view the videos that they're trying to view. So further along down the line, if, for example, a 14-year-old user is trying to view an 18+ movie, then we want to stop that at that point. We also want, for example, the first name. So this will be optional, and then the last name. So we can just use this to customize the UI a little bit further on down the line. Cool. So what we can do is we can say inside the controller that we want this user. So for example, the create user DTO to be a create user DTO. So what Nest will do under the hood is it will map that the request to that object for us. So the next thing that Nest allows us to do is to validate this as well using the same DTO. So it does this using the class validator and class transformer dependencies. So if we look at techniques and then we look validation. The way that it works is that the Nest call comes with validation pipe. And so what we need to do is we need to register these inside the app. So the pipes are, they're injectable classes that can either transform or validate the inputs into an application. So what we need to do is we need to install those dependencies. So if I do npm I and then save, I need the class validator and then class transformer. And then once those are installed, or while those are installing, what we need to do is we need to register that as a global pipe inside the main TS. So we can say app.use global pipes. And then this takes a list of arguments, but what we want is a new validation pipe. So this just ensures that for every one of the requests, it will pass through the validation pipe before it gets to the next stage. Once we add the validation to the create user DTO, we can ensure that this code here will only be reached if the validation is successful. So what we can do is add some decorators to this class now. So we can say, for example, that the email address, the password, and the date of birth are all required. So I can give those a decorator of is not empty. Cool. And if we just import that, from the class validator, so now hopefully that will be okay. For the email address, this should be an email as well. And then we can do some clever stuff with the date as well. So for example, we can say for the date of birth, we want this to be a date, so is date. So we can use the transformer to verify the type as well. So we use the type decorator. And if we import that, and then we want to say that that is a date. And then what we can do is we can use the max date validation. And this is kind of clever. So what we can do is we can say that for any request that comes in, the date of birth needs to be more than, for example, 13 years old. So if we take the moment library, so the moments are like a really popular library for working with dates. So for example, we can say we can create a moment and then we can add and subtract. So we can use this to subtract years. So for example, we can say that we want from now, so from the current moment, we want to subtract 13 years and then convert that to date. And then that'll validate that our date of birth is always greater than 13 years ago. Cool. So then what we can do is in the Auth Controller. So for now, what we can just do is just return the create user DTO. So this is a variable lesson that I picked up last week. Is that if we're running this in development mode, so what we could do to test this is we could just open up Postman and we could run a post request from there. What we should be doing instead is looking at tests. We can use the end-to-end testing. So when you use the nest new command, then you'll get an E2E test. So we can see inside like package.json that we have these commands. So we have test, we have test watch, which is basically running the test in watch mode. So every time you make a change, it will refresh the test. We have this E2E here, which is basically running Jest, but with a config. A look at that config. So basically saying just run all of the files that match this value. So any string which has .e2e spec.ts at the end of it, and then we'll run that using tsjest. So if I run that now, then basically it's going to fail. because if you remember, we changed the controller. So instead of just saying hello world, it was saying hello Neo4j user, there are these accounts in the database. So I guess what we can do for now is we're not using that route, so we could just cancel that out for now. So this is something I've seen as well, is that I think that there's some sort of project, some sort of problem somewhere down the line with the imports. So if I remove start as request and just change it for request, and that will fix that that problem there. Not quite sure why that happens, but it does. Yeah. So what we can do inside this test is we can create a new group. So we can use a describe function to create a group of tests. We can say, for example, we're testing the auth, all of the auth values, and then we can sort of create some tests in here. But if I say, for example, what we want to do now is we want to test the post auth register routes. So everything will now be nested, so we can tell exactly what's going on and where things are failing. It'd be an easy way to find it. So we use the if function to create a test. So a habit I've got into is to use this to form like a sentence. So it should do something, and then it will do a function which confirms that we can do something. But however you name it is up to you. So what we want to do is test firstly that it validates the request. So we can use super test. So this is like a really cool library which allows you to simulate requests to an API. So if we say return request, and then so this is the app that it needs to use. So in this case, we're using the app which is sort of generated here. And then what we want to do is get the HTTP server, which will be the underlying Express server. So you can say get HTTP server. And then we want to do a post request, so .post to /auth/register. I want to set the accept header to application/JSON. We want to send some information with it. So for example, the email, hello@example.com. And then we want to send a date of birth. I'm going to say 2019-01-01. So this is going to send a bad request, doesn't conform to the rules that we've defined inside this test. So what we want to say is we expect that the status code will be 400, and if it doesn't, then this test will fail. And we also want to expect that for the response, just for now, what we'll do, we'll just log out res.body just to see what's going on. So if you supply a number to expect, then it treats it as a status code, and it's basically shorthand for saying expect res.status code to be 400 or something like that. So if I just run this test again. So right now it's got a expected 400 bad request, but actually got 201. So by default, when you post something, it will give you a status code of 201. So what that means is at the moment, this isn't using our validation. So the validation pipe isn't working there. So actually what we need to do is the same as we did inside the app.js. We need to add that into the to the test app that we use as well. So we just add that into here. So now that will work. So essentially all you need to do is remember that anything you do inside this bootstrap function, you also need to do inside the testing function if you want to test it end to end. Cool. So if I run that test again, so now we should have a so we've got failing test. We've got the status code of 400 there, and we have some messages there which explain why it's been rejected. So there's a few things that we want to do to ensure that this is working properly. Is we want to So we use the expect function to say that the res.body.message. So that would be an array, so we can use toContain, which will allow us to search throughout the whole of the array to find a certain value. So we want to check that the password should not be empty. And we want to check as well that this date of birth thing is working as well. So because the date of birth is 2019, so it's clearly not 13 years ago. So we can do a check on that as well. This is the best way that I've found to do this so far, but if anyone has got a better idea of how to do this, then like shout. But basically I'm just using res.body and then finding a message inside there. So for that message, we want to find one where M starts with, and then this, so I didn't know maximal was a word, but maximal allowed date for date of birth. So regardless of what the date and time of the request is, then as long as that is at the start of the string, then we know that it's worked okay. So this function will return either one value or return null if that value isn't found. So we just want that to be defined. Cool. So if I run that again. Okay, so that's failed on this. So have I made a wrong mistake there? Oh, sorry. So m.body.message. Cool, perfect. So now we can remove that res.body because we know exactly what's happening there. And then this test should just run. And as you can see, so we've got auth, and then we've got the post, and then we've got the test inside there. This is now nested, so we've got the auth and then the post. And what I'm going to do is, this bugs the hell out of me. So I'm going to change this to 4. So that test is running, but what I can see here is that we've got a little one at the bottom. So Jess did not exit 1 second after the test run had completed. The way to solve this is we can use this detect open handles. So if I copy that and then add that to the E2E function. So detect open handles. Now if I run that again, it should tell me what the handle is that's still open, and we should be able to sort of fix it from there. So what is still open is this post request. So it looks like from something we're doing, I guess from the app server, it's not being sort of teared down properly after the test. So what we can do is we can add in the E2Es, we want to add a function. So this will run before all of the tests, and then we can say that after each, we want to close the app down. So we call app.close, and then that should fix the problem. So if we run that again, all good. So it's great. So it's now exited after that. So that solved that problem, that warning there. Awesome. So right now that's working, but it's not actually doing anything. So actually, so next thing we want to do is we want to add a test. It should return a HTTP 200 successful on successful registration. Cool. So we can copy the same thing sort of here. So what I'm going to do is I'm going to create a variable for the email address, and I'm just say like math random adamcowley.co.uk. So what this will do is, like every time the test runs, then it will create a random email address. So then the registration won't fail based on our unique constraint. We want this email to be this. So we say, for example, the password is let me in. The date is say year 2000, so that's sort of 20 years ago. And then we want to, the first name will just be Adam, and then last name Cowley. everything should now pass the validation steps. So we're expecting a TL01 created. And then at the moment, so the controller itself just returns the object. So we can just assert that the request.body res.body.email to be the email that we've supplied. So for now, that should be good enough to show that it's working. Awesome. Cool. So right now the test is passing, but it's not actually doing anything at the moment. So it's not persisting the data into Neo4j. So that's our next step. So bearing in mind that the Auth Controller shouldn't really hold any logic as to how the user is created, it should just accept the request and then pass the responsibility onto the user service class. What we'll do is we'll next look at the user service, and then we'll create a new method in there for creating a user. So if I go to the user service, so the first thing we should be doing really is defining like a type for what is exported from the service. So ideally this will probably sit somewhere else, but for now we can just include it here. And then we can refactor the code a little bit later on. So we want a type of user. And just for now, we'll just set this to be like an Neo4j node. So we can import the node type from Neo4j driver. So we can guarantee, for example, it's got like a properties object on there that we can get the properties of the node from. So next, what we want to do is in the constructor, we're going to be interacting with Neo4j using the Neo4j service. So we will inject a private read-only Neo4j service. The next thing we want to do is just create a function to create a user. And then it's an async function, so it will return a promise, and then it will resolve to a user. Cool. So inside this function, we can apply some business logic to it. So if we take a look at the kind of values that we are expecting from the create user DTO, you can say, for example, that we want an email address, which will be a string. We want a password, which will be a string. We want the date of birth, which will be a date. The first name is an optional string, and then last name is an optional string. Cool, and that will return something. Cool. So what I want to do is basically just run a Cypher query against the database to create this user. So we'll just run a create statement. So we'll say that the res will be an await of this .neo4j service.write. So we'll run a write query against the database with this query and set parameters. So I want to create a user node, and then I just basically just like a mass assignment. So I can say that u is properties. So I can just create a properties object inside this, and I can just pass the email, the password, date of birth, first name, and last name. And so what I want to do as well is I want to create a unique ID, so I can say that the u.id equals, and then I can use the random UUID function in Cypher. So if I, for example, return random UUID, it just creates me a UUID that I can use there. So it saves me having to use something like the UUID package, which I've used in the past in Node. Cool. So once we've got that response, we want to pull the user from that, so the user node, and set the res.records in the first record, and then we use the get function to get u. So if we return that user, and then if we return that, then that should be fine. So if anything goes wrong, an exception will be thrown. Otherwise, it will return a user, which under the hood is a Neo4j node. If I run this test, it will go through and it will create a random user for me. So now that's run. If I, for example, say match user where exists .email. Oh, sorry, so it's not there at the moment. Cool. Yeah. So if I in the Auth Controller, what I can do is I can, inside the constructor, inject the user service, and then I can say that the user is awaits this.user service.create, and then I want to pass through the information that is required in that user service. So I've got the email address, I've got the password, I've got the date of birth, first name and last name. So all that information comes off of the create user DTO. Cool. And this so this date of birth at the moment. So right now it's a string. So I just need to convert that into a date in order for that to go through. And then I can just return user.properties. So if I run that test again, res.body. So I'm running this in. So this is a problem that once you know what to do, it's really simple, it's really easy. But up until that point, it's kind of tricky. So basically, it's saying that Nest itself can't resolve the dependencies of the Auth controller. So please make sure that argument user service index O is available in the Auth module context. So in order to fix this, we need to ensure that Nest and the IOC container can recognize that service. So there's two steps that we need to do inside the Auth module. What we want to do is ensure that the Auth module imports the user module. So anything that is exposed from the user module is now available inside the Auth module. And then in the user module, what we want to do is add that as an exports. And everything's fine. Just to sort of unpack that a little bit. So we've registered the user service as something that is exported by the user module, which means that then when it is imported into the Auth module, because it's been exported, it's then available to be injected into anything inside that module. So if we have any module that imports the user module, then that user service will be available. Cool. So if I run those tests again, so we've got a 500 internal error there. So property values can only be primitive types. So if we double check what we've got inside here, so the date that we've passed through is a primitive JavaScript date. It's not a Neo4j date. So what we need to do is convert the date of birth into what would be a Neo4j date. So if we import the types from the Neo4j driver, this exposes all of the different native types inside Cypher and inside Neo4j. So as part of this, we've got the date type, and then we can use types.date. So the date of birth should be types.date, and then we can use from standard date. So that converts the native JavaScript date into the Neo4j date. So if I run that again, all good. So what it's done is it's created this this object with the first name, last name, the password. So right now it's unencrypted. We'll sort that out in a little bit. And you can see that the date of birth there is this kind of strange format. So it's got the year, month, and the day, which are Neo4j integers. So it just shows that we've converted the date from a JavaScript date into a Neo4j date. Cool. So if I go back now, so if I now find the user where the email property exists, I've now got one row there. So you can see that this has got an internal ID. It's got one label, which is user, and then for the properties, it's got all of the information that I've supplied, and also generated this ID property as well. So I can't stress this enough. Storing plain text passwords inside Neo4j is a really bad idea, and just exposes you up to all sorts of issues. So what we'll do is we'll create a new service and we will use bcrypt. So bcrypt is a popular JavaScript library for encryption and checking hashes. So we can install it by using npm install bcrypt, npm I save bcrypt. And then, so once that's done, so it gives us a few functions. So we've got, for example, the hash function, and then we've got the compare function. So the hash function will take a plain text string, take a set of or a number of salt rounds to add different salts to encrypt the password, and then the compare will take a plain text password and then compare it to a hash that's been hashed. Cool. So the next thing for me to do is to create a new module for encryption. So if I say Nest.js encryption, I'll do the same thing with the service as well. And then for the encryption service, I want to import from bcrypt the hash and compare functions. Cool. So this is going to be an injectable service. So for anything that imports the encryption module, we'll be able to inject that in. When we use the hash function, for example, we can supply this this value of what I will do. Configure that using the config service. So for that, inside the constructor, I'll add a private read-only config service. And then, for example, so for the hash function, so I want to take a plain string, and then the output will be the hashed string. And then, so what I want to do is I want to use the hash function. I want to hash the plain string. And so for the salt rounds, what I want to do is from the config service get a value. So it will be a number, and the key will be hash rounds, and then we'll default that to be 10. It seems to be the default that's used in the documentation. So for example, if I look in the .m file, I can say, for example, that the hash rounds will be 20. So it'll just give us an extra level of encryption there. Cool. And then to compare, so we create a compare function. We'll take the plain string and then the encrypted string. And then we want this to return a Boolean. True if the two strings match, and then false if they don't. And then we can return compare. And then we take the plain and the encrypted. So that's all we need to do for the encryption service. So that'll encrypt the password for us. So then what we need to do is in the encryption module, we want this to export the encryption service. And then, so we want to use this in the user service. So if I go into the user module and then just make sure that that imports the encryption module. And then inside the user service, I can then inject that in. So encryption service. Cool. So no errors in here, which is great. So that shows that we've imported the module correctly. And then for the password, we can say so we want to await this .encryption service .hash the password. So if I run the tests again, fine, cool. So if I look in the database again now, refresh this again, we should have a few users in there. You can see this is the latest one. So 54517. So in there, the password, you can see that's now encrypted. So now we have no idea what the user supplied as the password, and to be honest, we don't really want to know. We just want to know that it's what they give us equals that in the future. Cool. So now that's working. The data is being added to the database. So now a user can sign up. So if we just take the console.log out of there, so we've now got the user in there. So right now it's returning the user's properties. So it's still not returning a Jwt token. So what we want to do is we want to next create an endpoint, so like a post endpoint where we can post a username and password and then get a token in exchange. So in order to generate a token, we use Passport. So this is Passport. So it's a very popular library for Node.js. So basically, the Passport itself acts as like a middleware or a way of authenticating requests, and does that using strategies. So like in real basic terms, the way we'll be using it is that a Passport strategy will be a class which has a validate method. So what that will do is it will check the context of the request. So for example, the user's username and password or a token, and then throw some sort of error if something goes wrong, and then it stops the request from going further down the stack. So alongside that, we use Passport Local. So Passport Local is basically a strategy which sort of comes out of the box, which allows you to authenticate with username and password. And so on top of that as well, so we've got Nest.js Passport as well as a dependency, and then we've got Passport Local. So the Nest.js Passport will give us the relevant classes that we can extend in order to install that. So if I do an npm install on the Next.js Passport library, we want Passport itself, and then we want Passport Local, and then for the for TypeScript, we want to install the types as well for Passport Local. So I can say npm I and then say dev types Passport Local. So that'll give me all of the types and the type hinting in the ID and everything. Cool. So we'll need to create our own local strategy for Nest. And basically what this will allow us to do is to authenticate our requests using a username and password, or in our case, an email and password. So what we'll do is inside the auth folder, I will create source auth and then local.strategy.ts. So this needs to be an injectable class because it can be injected into the controllers that we use, and it will be a local strategy, and so this will extend the Passport strategy. Extends. Cool. So the Passport strategy will come from Passport. Nest.js/Passport. Cool. So basically, as I say, so this is something that will just be sort of brought up and fired. So for the Passport, we need a validate function. We'll take a username, which will be a string, and then a password, which will be a string. And then in return, it will do a promise of return a promise of anything. So basically, what we want to do inside this this method is we want to do something to check that the user is valid. If not, throw an exception. But if everything is okay, we want to return information about the user. So in this case, what will happen is the Passport strategy will Take the request. Anything that is returned from this value will be assigned to the request. So for example, request.user would be null if we return null here. So in terms of checking that the user is valid, so what we want to do is we want to pass this responsibility onto the auth service. So we'll take inside the constructor. Cool. So inside this, what we want to do is we want to inject the auth service. So private auth service. And then down here, what we want to do is say that we want to check the auth service. So we'll call validate user with the username and password. So it's got an error here at the moment saying that the constructors that derived must call super. So there's a parent class that this needs to call. And so by default, it will pass through we'll check for the username and password, and it will pull that from the body or the payload. But because we're using email, what we need to do is set the username field to be email. Instead of having the username pass through, it will now be the email address that's passed through because we're authenticating with the email. Cool. So we want to await for a user. So what this method will do is it will check the database for the user, then it will check the password. If everything is fine, then it will return a user. If not, it will throw an error message. So if we can say, for example, that if the user is falsy, then throw unauthorized exception, which comes from Nest.js common. Otherwise, we want to return that user. Cool. So if we go into the auth service now, we can implement this validate user method, which is what TypeScript's complaining about here at the moment. So auth service, validate user. So we'll get the email address, which is a string, and then the password, which will be a string as well. So there's two things that we need to do. So firstly, we want to get the user from the database. This shouldn't be the concern of the auth service. It should be passed on to another service which is responsible for the users. In this case, we have the user service, which we've already created for creating the user. So in the constructor, what we can do is we can inject that user service. And then what we want to do is say that the user is await this.user service. And then, so what we want to do is add like another method in there. So we'll say find by email with the email address. So if we implement that, so async find by email string. What we want to do is get a result from Neo4j. So we can use the Neo4j service to run a read query. And then we want to run match user with the email address of email. So we'll pass that through as a parameter, return EU. It's like res. And then, so this will either return a user or it will basically be undefined. So if res.records.length, so it should be await. So if res.records.length is 1, then that means that we have a user, otherwise it will be undefined. So if there's 1, then we can say res.records 0 to get the first one, .get u, which will get us this view here. Otherwise return undefined, and then we'll return that statement. Cool, so if we head back into the auth service. So first we want to create find the user in the database. So next thing we want to do is check the username and password, check the authentication. So if we inject the encryption service, and we'll say that if user is not undefined, and then we can use the encryption service to compare the plain string, so the plain password with the encrypted one. So this will be user.properties.password, so that'll be the encrypted password. Then we'll return the user record. Otherwise, we'll just return null. So TypeScript doesn't like this, so it says that password doesn't exist on type of property. So what we can just say is a record of string and any, just to cast that. Awesome. So again, we've got this this error here saying that the Nest can't resolve a dependency. So for the auth service, it recognizes the user service but doesn't recognize the encryption service. So if we go back into the auth module, Awesome. So it gets easier. The more you see that message, the easier it is to decode, I promise you. But it's a challenge. So now our auth service will either validate the user. If everything is fine, it will return something. Otherwise, it will return nothing. So then if we go back into the local strategy, if the password is fine, then it will return a user. Otherwise, it will just return nothing, in which case we throw an unauthorized exception, and then it will pass through. So once the request comes through, this user will be set to request.user. So next thing we need to do is to add it as a guard. So if we take a look at the definition for a guard, the guards have a single responsibility of guarding a root. So if you add a guard to, for example, a controller, so if we add it to a root, basically what it will mean is the guard will stop any request getting to that point if it fails. So basically, we want to create a guard that goes with the auth strategy. So, for example, we can say we can touch the auth and then the local guard. Sorry, local auth guard. Cool. So this will be injectable. And then we want to export the class local auth guard. And then we want to, in this, extend the auth guard, which is supplied by Nest.js Passport. We'll give that a name of local. So that's all we need to do for that one. So if we go back into the controller, we'll create a new method. So post login async. Post login. So if we use the use guards decorator, and then we say local auth guard. So now that guard will protect this root. So given that the local auth guard will do the authentication for us using the strategy. So the request will come in. Passport and the combination of Passport and Nest.js Passport will take the extract the email address and password and then pass it through to this validate function. Whichever value is returned from this validate method will be added to the request. So in the controller, what we can do is use the request decorator to inject in the request. And then all we need to do is just return request.user. And then that will give us the value. So actually what we need to do is return request.user.properties. and then it will return the properties for that user. If I go into the tests, and then we create a new group, post auth/login. So what I can do with this is, because it's like an end-to-end test, right now we're basically testing the flow from start to finish. So right now the correct credentials are only available inside the scope of this test. So what I can do is I can move up the email into this auth block. And then it means that for all of these tests, so for example, auth register, and then for auth login, I can use the same details as well. So I can also set a password there as well. And then we can use that to then test the login routes as well. Cool. So if I remove let me in there. Cool. So if I do a post request to auth login, so it should double check. So it's a 401 status if you give a bad username or password. So if username does not exist, cool. So we want to send username unknown, so the email address of unknown, and then password can be anything. So we expect when that happens, it should return a 401. Same thing if there's if the password is incorrect. So we can take the email that we set above and then use something else as the password. If I run that test, it should pass. Okay, unknown authentication strategy local. So there's some registration that we need to do inside this. So in order to get over that, we need to go into the Auth module, and then we need to register the strategy. So it should be a provider, so the local strategy. Cool. Okay, so now we've got a different error, so it should be 401, but it's returning a 201 created. So if we should return 401 if the password is incorrect. So if we, for example, expect, just log out the body to see what we're actually returning from that. So it looks like that is finding that user. Cool. So if you follow it through the stack, then we get to this point. Change on site looks okay. So compare the password to the password on there. So let's go back to the good old-fashioned login. So we have to await that because it's an async function. So I made that mistake yesterday as well. Cool. So now it should be okay. Perfect. So now everything passes. We've got that 401 unauthorized. Cool. And then, so what we want to do is we want a 201, and then we expect for the response, we expect res.body.email to be the email. Perfect. So that works. That test passed. Cool. So the username and password are correct. So the email is fine. That's good. So right now we're returning the information for the user, but we're still not returning this this Jwt token. So basically, what we want to do is return a Jwt token. So a Jwt token will look a little bit like this. So when it's encoded, so it's base 64 encoded information. It comes with 3 pieces of information. So it comes with a header. So that contains like the type of token, and then the algorithm that's used to sign it. There is a payload as well. So that's a base 64 encoded object that includes information about that user. So for example, you'd have the subject or sub, and then you have an expiration time. And then it has a signature at the bottom. So the value is signed using either a secret like passphrase or a token, and then the signature is added there. So if somebody tries to tamper with the payload, then the signature will be invalidated and it won't work. So I guess it's important to remember at this point that you shouldn't any sensitive information into this payload. These can be easily decoded, so it's only just like basic 64 encoded information. So make sure there's no passwords or anything in there like that. But basically, what we want to do is just to add in as much information as we need in order to for like the front end applications or the UIs to personalize the service. Things like displaying somebody's picture or name in the top right hand corner or something like that. So in order to generate the JWT, we can use the Passport Jwt Module. So again, this is another strategy for Passport, but instead of using username and password like the local one, we are instead using a JSON web token. So to install that, we use npm-i, and then we'll save Passport Jwt. And then there's also a Nest.js JWT package, which provides all of the integration things that we need, the different classes and things like that we need to extend. What we need to do is we need to register the JWT module, which comes from Next.js JWT, in with our Authentication module. And along with that, what we do is we use the config service as well. So similar to what we did with the Neo4j service, we'll take some information from the .env. So for example, I've got the JWT secret and the expires in inside there. So what this means is that if we change environments or when we're loading into a test environment, live environment, we can use environment variables instead of having to hard code something into the application, which makes it a lot easier to change, a lot easier to rotate keys and things like that. So if we look at the Nest.js/passport, and then we look for the JWT in here. So basically what this does is it has the in the start, it creates like a JWT constants variable and then keeps the secret inside there, and then registers it using like a require. We're going to take that a step further and just use the config service from the outset. So if I open the Auth module, so what I want to do inside here is register the JWT module. Oh, IntelliSense. Yeah, cool. So that's the mode that we want. So we can either use register, like it has in the documentation, and that will just take the static values. But we can use register async instead, and we can provide an object. So if I import that. JWT. Cool, so that should give us some hints now as to what we should be doing. If we take a look at the app module, and then we take a look at the way that we registered the Neo4j in async mode. So we use this imports to import in the config module. Then used inject to inject a value into this factory function. So use factory would return, in this case, the Neo4j config. So what we're going to do is kind of the same thing, but we want to do it with the JWT instead. So you can see from the configuration that we want to return a secret, and then we want sign-in options with an expiry inside there. So basically what I want to do is say that I want to import the config module. From that, I want to inject the config service into this factory function. So use factory and we want a function here which takes the config service. And then returns an object. And then we want, so the secret is config service dot get. It should be a string. And then if we check the end file, we want this JWT secret. And then for the sign options, what I've done for this is I've put the expires in to be 30 days. Just because, you know, when I log into, for example, Netflix, it's kept me logged in for months. But essentially, other than that, what we could do is we could create, like, for example, a refresh token. But for now, we won't worry too much about that. We'll just set the default to be 30 days. So we want the expires in value from there. Cool, so that's good. There's no errors in the console at the moment, so we can assume that's been registered. And then, like the local strategy, we want to create a JWT strategy now. So if I touch source auth and then JWT strategy, and then again we want to do the same thing with the JWT auth guard as well. So we'll use that a little bit later on. Cool. So for the JWT strategy, so again, we want this to be injectable. I want to export a class of JWT strategy, which extends Passport Strategy. And then the strategy, so the annoying thing about this is that I want a different strategy, but I can't ever see it there. So it's not the strategy from Passport Local, it's from Passport JWT instead. Cool. So for the constructor, so I basically need to call the super again in order to get that to work. So if we take a look at the documentation, so there's a few things we need to do inside that super. So we need to set the JWT from request. We just use this extract JWT dot from auth header as bearer token to instruct the strategy how to pull that value. So JWT from request is extract. So if I just copy and paste from that, it says inside the documentation that this ignore expiration. So by default it's false, but I guess it's just good to be explicit about ignoring the expiration. So if you have, like, for example, like short-lived tokens, what you could do if you wanted to keep a user logged in is you could have a token. Inside that token, you could encode a refresh token. Refresh token would be a longer-lived one. And what you could do is instead of just checking the expiration, what you could do is store that token in the database and then use that to then generate a new short-lived token. So you don't necessarily block them out based on the expiration, but you then have a second check. We won't worry about that for now. We'll just go with false. So we have the secret or key. So we need to get this from the config service. So if we inject that in, private read-only config service, which is a config service. And then we can say config service.get string of JWT secret. So if we didn't do that, if we sort of hard coded that into here, when we sign something with the module, if the secret or key was different, then we wouldn't be able to read our own keys. So essentially, we can use the config service to use the same value. So like the local strategy, we can also use validate. Then we want the payload. So right now this is any, but I guess in future what we might want to do is to define the structure as its own interface or type. So we could assure that certain information was on that token, and then have the types for that. Inside the payload, there will be payload.email, and then there'll be, for example, like payload.dateofbirth, whatever we encoded in there before. So we want to take from that payload, we want to get the email, and then we want to check the database for that, and then basically return that user. So this should return the same as the local strategy. So if we check that, it's got a promise. It should be a promise of user. So we can always guarantee that user is being returned. Cool. So in order to get that user, what we want to do is create an instance. Inject in an instance of the user service. Cool. And then we want to return this dot user service defined by email. Payload.email. So like with the local strategy, if the user doesn't exist, then it throws an unauthorized exception. So like in theory, even if the token that's signed is valid, but for example, we've deleted the user account, then we don't want to let that user in, so we can do exactly the same thing here. So we await that. So if user is not defined, then we throw an exception. Otherwise, we return the user. Cool. For the Jwt auth guard, again, we want to make this injectable. We want to export a class called Jwt auth guard. And we want to extend auth guard, and then we'll give that a name of Jwt. And then that'll be picked up by Nest. Cool. And if we add that into the Auth module as a provider, Jwt Strategy. Cool. So to prove that this works, we can go back into the Auth Controller. So we can create a get endpoint here. So like get/auth/user, and then it will be async. So get user. We want to pass in the request. And again, we can return request.user.properties. And then we want to use that guard that we just created, so Jwt auth guard. Cool. So if I go back into the tests, and then we'll create a new, so auth, and call that auth user. So what we can do is, so we've got the login and we've got the register. So ideally we want to test that both of those are working, but for now we won't worry too much about that. What I'll do is I'll create a token variable here, and then we can say, for example, on the login request, when it's successful, I can say that. So instead of the body being there, we want the access token. We want that to be defined. And then we can set the token to be that. Cool. And then to test that should work. So it should authenticate the user. With the Jwt token. Cool. So if we do, instead of a post request this time, we do a GET request. So the GET request is to auth/user. I want to set the authorization header to be a bearer token with the value of token. So we would expect it to be a 200, so 200 OK. And then for the response, again, we want to we expect that the res.body.email to be the email that we've supplied. So these should return a token, and then we can then use that token to get the actual information from the user, or like a more comprehensive view of the user than is stored inside the token. So if I update this one as well. So if I run the tests, so these are going to fail again, and because we're still not returning a token, we're still returning the user's details. So right here we're returning the user properties. We're not actually returning a token. So what we can do is, so basically what we're going to do is inside the auth service, we want to be able to create a token for that user. So if we, for example, async create token. So this will take a single argument, which will be the user, so like our user node. What we want to do is like deconstruct the properties to return some information, that user, and then we want to encode that into a JWT. Cool. So for example, we can say some things will come from user.properties. So for example, we can take the ID, we can take the email address, the date of birth, first name and the last name from the properties. So it doesn't like this because, again, it's the Neo4j driver thinks this isn't an object. But actually, what we can do is we can guarantee that this is a record where the key is a string and a value is any. What we want to do from here is we want to use the Jwt service to generate that token. So we've registered the Jwt module, so it's kind of the same as we've done with our own module, so this is just one that's been provided by somebody else. So the Jwt module is a Jwt service. Is the Jwt service. So from Nest.js. So that has a method on there called sign, and that basically signs a payload, which could be a string, could be an object, could be anything. So what we'll do is we'll pass through so some information there. So the sub, we want the so that's kind of the subject. So assign that to be the user ID, and then we'll take the rest of the values and just assign those straight onto that payload. And then that would generate a token. It will return basically a string. Actually, what we want to do is return that inside an object. So that will be the access token. Get the brackets in the right place. All good. The auth service takes a user and then generates the token for them. So if we go back into the Auth Controller, here we've got a user. What we need to do first is inject the auth service. And then we can return .auth service .create token. We create the token for that user. Cool. We can do the same thing for the post login. So instead of that, then we take request.user, and then that one remains the same. So then if, for example, we take the post register, so access token should be defined. So if we log res.body, we should see that there's now a token on there. Same thing for this. If you just log that out as well. Cool, so a few are passing. So here we've got the access token, which has been logged from there. So it shows that's coming out. So our failed test is 401 when authenticating with the auth token. So I have to double check that one. Cool, so if we walk through what's happening, so from the Auth Controller, we get a GET request to /user with that authorization. So that is guarded by this Jwt auth guard, which we use our Jwt strategy. And so something's happening here, which is a little bit strange. Yeah, so the bearer it's undefined. So that's why it's not working. So that goes to prove that if you don't have a token, then you're going to get a 400 request, which is good. So if we remove that let, and then if we run that again, fingers crossed, everything should be fine. Cool, so everything is now passing, so that's now working perfectly. So if we just another test in there to say confirm that it should so if no token is provided, it should be 401. So if the incorrect token should now have 3 passing tests for that one. So we're not getting an email there at the moment for the, oh, sorry. I'll remove that, so that should be fine. Cool. So if it's unauthorized, if there's no token provided, it should just be a 401. There shouldn't be any properties on the return. Same if the token is incorrect. If there's a prop JWT token, everything should be fine. Perfect. So right now it's still returning information about the person, so we should probably hide that. So we've also got in the Jwt strategy, we still got that console log. So we want the email, but we want res.body.password to be undefined. So we can say, for example, that I want the ID, the email, date of birth, first name, and last name is request user properties. And we just return all of that information, and then we'll turn the date of birth as turn that as ISO string. Cool. So now we've got all that information there. So we've got the ID, email, first name, last name. We're not exposing the password, and can guarantee that we're not exposing the password. We've got the date of birth there as the ISO string as well. So what we have done is we've created a user module, provides a service for interacting with the users in the database. So this service now allows us to either create a user or finds the user by its email address. The auth service will allow us to find a user via the user service and then validate that the password that has been provided is correct. If everything is fine for both those methods, then we are generating a JWT token, which can be used by the UI. We've got guards that detect a route based on the JWT token that's been supplied. We've also got end-to-end tests that ensure that the user registration and authentication flow will work as expected. So next week, we will look at authorization, making sure that a user is actually allowed to do what they want to do. So in terms of the code that we've written today, I'll commit everything and push it in the next 5 minutes. So if you're watching this back on YouTube, then everything should be there and should be ready for you. If you want to read in more detail as to what we've done, inside the docs, there's this authentication Markdown file, which basically talks through everything that I've gone through today. If you've got any questions, comments, any issues, feel free to get in touch with me. You can either create an issue on the project or you can contact me. So my email is adam@neo4j.com, or you can catch me on Twitter @AdamCowley, or you can join the conversation at the Neo4j community site.